As they introduced me, I'm Warren Parad. I'm the CTO at Authress, which is a widely used authentication and authorization API. And I guess I should explain a little bit about that, what that is. So here's the obligatory introduction for 2 seconds about that. Fundamentally, it helps protect APIs, provides user identity, access control, API key management, hosted login screens, audit trails, reporting, help additional security tools for B2B. So all of this is Authress. Okay, now Authress is fundamentally an API, so we get a lot of requests. So let's talk about that. Today in the world, there's about 1 trillion requests per second in the public internet. That's a fair bit. And from recent research published by Akamai, about 83% of these requests are programmatic in nature. That's machine clients, service clients, IoT devices, and the like. And from our own research, 4.9% of these requests are malicious in nature. That means for every 20 requests you get into your service, 1 of those is from a malicious attacker who's attempting to compromise your service. And I think we're all in this room today, hopefully, because we know we have to do something about it. From the last presentation, there's quite a few things we could be doing. There's so many, in fact, that if I were to stand up here and talk through each and every one of these, we'd be here long into the hours of the morning. Luckily, I'm not going to do that because I've heard there's a great after party that we're all supposed to get to. Yeah, that's a joke, right? But also doing that won't necessarily have the impact that we want it to. And that's because it may not be relevant for the service that we're building, the functionality that we have. What we really need to protect against are the sorts of things which are relevant for the infrastructure that we've created, the data that we have, and even the cloud provider that we've chosen. Intentionally deciding what attacks we need to consider is known as building a threat model. Utilizing what we know about our service, we can hopefully stop attacks before they happen. Now, these are going to be unique based off of the product that we're building, types of features we have, what we think attackers may be interested in, all to get access to your sensitive data. However, I'm going to suggest that many, if not all, APIs have a common threat model that we can hopefully utilize to build up specific solutions to stop attacks. So let's get into that. The first up are injection attacks. These are any sort of attack where a malicious attacker will attempt to construct custom payloads to get around whatever security we have in place. Common strategies for this are SQL injection attacks, where an attacker will attempt to craft some sort of SQL or payload into our service to get around those security barriers and execute a command against our SQL or whatever sort of database we're using, such as drop all tables. Another sort of injection attack is one in which they attempt to use the custom payload to execute a privileged action against our host operating system, or virtualization layer if we're using some sort of container. And the last kind of injection attack is one known as server-side request forgery. That's just a convoluted way of saying you have some credentials in your service which are used to interact with a third-party service provider, say a payment processor such as Stripe or a cloud provider of your choice, right? And an attacker will attempt to convince your service to utilize those credentials on its behalf. So let's all add these to our common threat model of things that we all need to handle in order to protect our service. But I don't want to just stop there. The application security program, OWASP, has detailed a couple of very important concerns for their security API. I'm messing around with the screen here. And number 2 for them is broken authentication. This is the authentication we've added to our service to identify users is either completely not present in any way, or what we have introduced in order to verify the users that are coming into our service, it's broken, right? And this is number 2. That should say a lot, that just not having authentication isn't even the top concern. The number 1 is BOLA, or broken object level authorization. This is realistically where a threat actor attempts to get into your service and compromise your sensitive data by utilizing the roles and permissions that you've assigned that user or via the what they've been granted themselves, because fundamentally it's the result of not having granular enough permissions or permission model within your services. And the attacks don't just stop there. We can add these into our threat model. We also need to consider the ones in which a threat actor will attempt to compromise our service, utilizing our APIs and services to take down potentially our infrastructure, maybe through a DDoS attack, a distributed denial of service. These attacks will not come directly into our API, but through our API, take down our infrastructure by issuing too many requests. And it goes further than that, right? We learned in the last presentation about issues with the supply chain ejection attacks, compromising our software, our dependencies, whether they're software or otherwise, hardware, et cetera, if you're buying machines from a suspicious manufacturer. And the last kind is some sort of threat actor will attempt to compromise your services through physical intrusion into your data center if you're running something on-prem, or through your virtualization layer if you're using a cloud provider, or even the cloud provider itself. And I would be a little remiss if I didn't also include making sure you're paying attention to those threats that are specific to your service. While we all have features and functionality which are relevant, when you're adding those to your service for your product, an attacker will attempt to utilize those exact features that you're adding in as the mechanism for egress into your service and compromising it. So just as an example, in Authress, we offer multi-tenant security capabilities to our customers. This means customizable identity providers, roles, resources, permissions, URLs. And the threat actors in our model will attempt to compromise our service and gain access to our tenants or our customers' tenants by giving us malicious data. So while this threat vector is specific for us, and you'll have ones that are specific to you. Okay, so we throw this into our threat model as well, and now we have a good common picture of all the threats that we hopefully need to handle. So let's talk about solutions. Before this point, we're definitely not ready to handle solutions, but since we've talked about the threat model, we're now ready. So let's talk about the first one. To deal with the threat to our services via injection attacks, we can have input validation. And I feel kind of silly putting this in the presentation because I feel like everyone in the audience knows what this is. But I'm reminded every single week by some large company out there with a well-known brand that they forgot to do this simple step. Maybe it's not so simple. I'm frequently reminded of this. And in order to do input validation, we actually need to know what our expectations are. Well, we actually need to know whether or not those requests coming into our service match our expectations, whether or not what they are sending us actually should be consumed in an appropriate way, or whether or not we need to do something and block those requests coming in. But that means we actually need to have thought about what our expectations are, how our service should actually work, which is not so obvious in every case. Now, we actually have to do the same step of thinking about what requests we should allow into our service in order to document our APIs and our products and our architecture for our users to actually consume it effectively. Well, when I think about documenting our APIs, I think about the Open API specification. This is an easy way to document programmatically what our service actually includes. This enables our users to actually consume our APIs, and then hopefully we can take this to the next step. Just as a quick example, if you're unfamiliar with this, or just to recap very quickly, in Authress we have user group management, and on the left-hand side you can see an indication of a JSON snippet which represents this, how to actually consume it. And by using standard Open API specification-based tools and whatever of your favorite languages, you can even generate a automatic UI which converts this programmatic documentation into something that's usable. Well, now that we've actually documented our API, we can actually take that next step and validate the requests that are coming into our service. And given whatever language or framework you're using, I don't want to say every language, but I'm pretty sure that there are libraries out there that can take this programmatic documentation and actually validate what's coming in to your APIs. Well, there is a little bit of a problem here where every time we add an additional endpoint to our services, we may end up with a problem where they're not secured by default. So rather than having to explicitly write some code to validate every single new endpoint we add, I suggest creating up a security middleware. This is some code that will get executed on every request. So here I've got actually an example of one of these security middlewares I've written in JavaScript. And I've highlighted the important section of input validation, where it takes out the method, path, query, headers, and body that we are getting in from our potential client requester. And we just pass this to the OpenAPI validator. And just like that, we hopefully have eliminated all the injection attacks that we can possibly imagine. There's, of course, some security in these SDKs to begin with, plus the definitions that we've defined based off of our expectations. What does this actually look like? Well, here's a log from one of our services with some important bits that I'm going to call out. The first one is the method, where we can actually utilize this to filter our API to documentation to find the actual part that we want to validate, as well as a templated path and the actual raw path for both logging, investigation later, but fundamentally to actually validate what these parameters are. For us, what an important aspect is in this particular string, which not everyone will be able to see, is the resource URI that can be used to validate actual authorization. An attacker can stick in some arbitrary string here to try to get our service to do something that we're not expecting. Luckily, the OpenAPI specification, documented correctly, allows the libraries to validate this, so that instead of getting in the appropriate library, if we get something nonsensical like this, which looks like a JavaScript injection attack for a UI, it's automatically stopped. This doesn't match our expectations. So whereas you may be missing input validation, this could cause some damage. Like this, there's no problem. But now that we're opening up the request, we shouldn't just stop there. We can actually take to the next step of adding authentication. And authentication is required because if we don't know who the user is that's coming into our service, we have no way of identifying if they're a malicious attacker for requests to come. We can potentially try to use the IP addresses, although if you're familiar with the IP address space, right now IPv4 is pretty much on the way out, which makes trying to stop attackers by tracking IP addresses next to worthless. We could try some advanced fingerprinting strategy, although if you're familiar with ad tech space or identity space at all, you'll know that this is becoming exceedingly difficult to do because all the tragedy of the commons here, the ad producers of the world are utilizing this to customize ads to you. So we can no longer use this in the security side as a meaningful way to actually validate requests. So identity it is. And by adding the authentication to our security middleware, we can close out the broken authentication attack on all future endpoints that would come for us. This usually involves having a trusted identity provider within our service. A trusted identity provider will generate tokens via login for users, service clients, third-party clients, APIs, etc., by going to some UI or API. The generation of these is usually a JSON web token, which then is sent to our API. And we can validate it by pulling out some information from the trusted identity provider and validate these tokens. If you're unfamiliar with JWTs, I have a quick example up here, which includes some important details. Normally, this is encoded in a way, base64 with some extra periods thrown in, but it fundamentally includes these properties. The source identity provider where the token came from. This one's our service, so I just threw it in here. The user ID who represents the entity that is actually calling your service. Maybe a user ID property, or if it's compliant with the OpenID or OAuth specifications, it will be the subject property. It usually contains an expiry to make this token limited lifetime so that if it does get out into the world, it probably will not be able to be used. And just as importantly, a signature that allows you to validate that the tokens you get into your API are actually indeed authentic. So like this, we can hope to actually close out the broken authentication by adding this authentication verification into our security middleware. So just after input validation, we can add in some extra execution here. Get out the user ID and identity provider when passed in a token. And hopefully we're done. Now, I do want to caution there's a tempting reality to say, hey, wait a second. All of our APIs, all of our endpoints on all of our services need to have the same functionality. Wouldn't it be great if there was some component within our architecture, our organization, our platform, our company that handled all this for us? Well, the reality is that when you build a service or API, you're accountable for the security of that resource, which means that you have to validate wherever the request is coming from, irrespective of whether or not you have another component in your platform. So even if you add something like a gateway to your architecture, you're left with two options. The first one is completely ignore that it's even there, right? Get the JWTs from your trusted identity provider and validate them, and don't go further than that. You're doing the same job as if that resource wasn't available, that appliance wasn't there. The alternative is to say, well, we're not going to trust the trusted identity provider, and instead we're going to trust tokens or some other validation from the gateway is available in our service. I mean, no one would think of just not having authentication verification at all in their service. They're at least going to pick one of these two things. The problem with that is you're basically saying the identity provider isn't doing its job. It's not providing us the functionality that we may require or the security, and that's why we've opted to add in this extra appliance. Well, not only does this make your request to your service less performant, it's a good reminder to take a look and be like, well, we don't have to use this identity provider. Maybe there's another one out there that actually meets our threat model that we're considering. And with explicit JWT validation, we're able to completely eliminate the broken authentication, assuming that you aren't using one of those libraries on NPM that has a misspelled name in it. The truth is actually on NPM, you can find libraries that are distributed by specific companies by using the group or the namespace at and then the actual name, like ours are all at Authress. You don't have to spell the thing right as long as you get the first part of the organization. So a lot of trustworthy ones out there will use that rather than namespace ones. But there's an important part of this, of authentication, and that's that just because we've identified the user doesn't mean that our service is now secure, because identity is not security. Just because we know who the user is doesn't mean they're not malicious. They have a valid token, but they may not actually have access to the endpoint that they are attempting to call. So we need to take a step further and close out the broken object level authorization by adding first class authorization into our service. Well, the very simplest way of doing this is by adding additional permissions specifically into our JWT. I like calling this simple JWT auth. Now, you'll notice that there are no resources listed here, and that's very important. But fundamentally, this is the bare minimum to actually add access control to your services. And it only works in very simple cases where the data isn't really shared between users. So you can think of like an offline video game, for instance, or a social media platform where all the data is public anyway. And there's a third case where all the user personas are basically the same and the permissions don't really amount to that much. So there are some cases where this is valuable, but most of the time we will realize that it's insufficient to actually stop the attacks in our threat model. And that's because it doesn't offer granular enough access control for our systems, for our services, for our platforms, for our APIs. We need something more sophisticated, such as a resource-based access control solution. So let's talk about what that is. In resource-based access control, you fundamentally assign for users specific permissions to explicit resources. And only once you have all three of these can you actually check to see whether or not the user, the specific request, is authorized. And just like we did for the previous threats in our threat model and the solutions that we've implemented, we can take this and add it in to our security middleware. Now, in this example, I've actually pulled out the request from the Authress SDK, but you can, of course, pass in the permissions and user and resources into whatever provider's SDK that you're utilizing, assuming you've got one. Hopefully you didn't build something custom. Maybe you were a little bit more adventurous within your teams than you probably should have been when it comes to security. Just to have a concrete example for this, you can imagine some apps in the world where this could be utilized. I'm going to, for example, use expense reporting. If you're unfamiliar with what this is, you rack up expenses in your company and you want your company to reimburse you. So what does that actually look like in practice? Well, not everyone in your company, or maybe everyone, but not everyone in the world should be able to access the expense reporting app and submit reimbursements. Malicious attacker could drain your company's bank account. So instead, you're going to check for very specific requirements. Well, you're going to pass in the employee's user ID, as well as some resource path that's relevant, and the permission that's specific for this situation. That's reports create, or whatever arbitrary strings you've decided on in your application. And with granular and resource-based access control, we can scope the permissions down to only what is absolutely required and no greater. And this is known as the principle of least privilege. The more granular a solution we have, the more secure it is. And this should be self-evident. that users who have access to more than they need to or more than they should means that they can do more than they should or more than they need to. And when practiced, even if a malicious attacker is able to impersonate a user or gain access to one of their credentials, they're limited in the scope of what they can execute against your service. There's a number of companies out there that publicly had an issue where their internal administrators lost access to their own systems to malicious attackers. Because those administrators were granted access more to the system than they needed to, the malicious attackers were able to do things like execute MFA resets for all the users of the platform. The principle of least privilege and granular authorization is the only reliable way to prevent broken object level authorization BOLA. Don't be this company, the company that requests to delete all of my calendars and all of my emails. Please, please don't be this company. I mean, there are realistic needs to utilize some of my user data. Maybe you're a platform that deals with calendars and you want to be able to book appointments. Great. So you should be able to ask me just for access to create appointments on my calendars and delete those specific appointments. This is a real company, by the way. I didn't make this up for the presentation. It exists. And really think about what happens when your database of credentials gets exposed to the internet. Well, in that situation, that means that those credentials could be utilized by the attacker to delete all my calendars and all of my emails. You don't need that. Also, don't be this company that lets people ask for this permission, right? Like, there's no reason to do this. There's no reason to not let me just uncheck, permanently delete, right? I should be able to just approve some of these and not everything in this one box here. Okay, so this is as far as we can actually get at the individual request level up to now with a security middleware. In order to deal with the other threats in our threat model, we actually need to take a look at our entire architecture as a whole and see if there's anything that we can do to deal with patterns across multiple requests. Think about those DDoS attacks and other infrastructure level threats. And to do that, we're going to add active monitoring and logging. I just want to make sure I'm on time here. And we can accomplish this by adding not just straight logging like this thing happened, but very specifically adding the full request and response, the status code, and whether or not, most importantly, that the request was actually authorized. I showed an example earlier about some of the logs that we have in one of our services. So what realistically we need to do is throw in a component into our architecture that can actually help detect when there's a problem. To dynamically block requests as they happen, we can insert what's usually known as an API firewall or sometimes as a web application firewall. Lots of cloud providers have them, as well as some other CDNs out there. They will watch for malicious activity or anything that's potentially suspicious. And by monitoring this, they can actually update the rules or execute those rules if they're managed in some way to stop an attack as it happens. A single request coming into your service by an authorized user, both by the identity provider who matches the token, as well as having access to that particular endpoint, may seem like it's totally okay. But a pattern of 100,000 requests per second with that exact same pattern for sure tells you that that's a malicious attack, that they're attempting to take down your service. Unless you have that pattern in your service, and then I imagine that there's some way that you can optimize it. So in practice, what this looks like is we take a component and we throw it into our architecture. We insert the API firewall and requests come in and are validated. Now, maybe if you're using one of these cloud providers options, there's a set of totally managed rules in there that will look for obvious problematic patterns. Maybe there's a potential string in one of the headers, which is known to be problematic, or a Java-based execution path, which if plugged into a famous logging framework for Java would execute remote command injection execution on the host operating system. But even if those rules don't fire, you'll get these logs into your service via the normal request. Remember, we're logging this. And then we can take those and correlate what's going on there and potentially write our own processor, which gets that data, sees what's going on there, and then goes and dynamically updates our rules in our API firewall. So you do notice one of those IP addresses, attacks are coming in through there very frequently of the same pattern. And while the managed rules may not help, you can dynamically throw something in here. So if you're getting an attack at that moment, it will actually be stopped. And of course, these rules live on into the future, much longer. so that future attacks are also automatically stopped. If you add logging and monitoring into your platform for your services, you'll immediately probably see something like this. Now, who of you thinks this is a problem? If you saw this in your platform, would you scream up and down that you're being attacked? Now, I mean, the truth is we don't know, right? I mean, realistically, users' behavior changes all the time. This could be an accident on their side, or this could be legitimately an attack where someone just is probably running some sort of port scanner or vulnerability scanner against our API from a malicious entity attempting to find what we have. So we need to go further than that. And what I'm going to say is that for our monitoring and logging, what we actually need to do is check out things that are relevant to our product specifically. So for us, we track what we call the authorization ratio. That's a complex formula that involves the number of requests that are coming in with the ones that are authorized versus the ones that we've explicitly blocked in some way, either because they don't have direct access, or their token is invalid, or they've included some nonsensical data in hopes to compromise our WordPress installation. We don't have a WordPress installation. But we get .php requests all the time. It's taken us some effort to exclude those from our logging because we don't want to know about it. This particular instance actually was the result of two independent problems. Our anomaly detection caught this. Our API firewall identified it for us through the authorization ratio. And it created an alert. And that alert went to our team, and we did a little bit of investigation. And in extreme cases, it may have actually just completely terminated the request. But when it's not that bad and doesn't cause us a consumption of high amount of resources or money or effort to investigate, we usually let it go through so we can collect evidence for validation later. However, sometimes we can't handle or know that every single thing that's coming in is actually a problem. We need to rely on our customers. And that's because things may fall into what is known as a gray area. That's, to you, everything's fine, but to your customers, there's a real problem. Maybe the latency or throughput is just increased or degraded enough that for them it's a real problem. Like they'll end up clicking, refresh on the page too many times. So to help with this, we actually expose some of these problems where they're still below our thresholds, but could be interesting because our customers know what they're doing. And we throw this into a dashboard. Our customers may know that there's actually a problem for them, and they can feed back this information to us. Now, I really have to suggest here that I think it's a great idea for every application that you've got to show these sorts of metrics to your customers, especially if you're in the B2B space. It can help them also identify when there's problems. I get those emails, I won't say all the time, but frequently enough to say, hey, if someone tried to log into your account, here's the two-factor auth code, TOTP, that you're getting into your email. If it wasn't you, ignore it. I'm like, well, it wasn't me, but you should do something about it. Telling me to ignore it isn't sufficient for the problem. Maybe I just don't feel like entering that code right now. Don't do anything about it. But with appropriate monitoring and logging, we can start to stop the threats in our threat model, such as the DDoS attack. At this point, I want to review what we have so far. I talked a lot about the threat model, and most importantly, we have to model that. And the one that I created here is the injection attacks, broken user authentication, the broken object level authorization, and DDoS attacks. So for each of these, only after defining the threat model was I able to specifically come up with solutions. Before that would have been too soon. The first one being validated the inputs, then adding user identity, granular access control, and lastly, dynamic rules. And it's great when everything goes to plan and we think about our threats and then add the solutions. But sometimes we find ourselves implementing things that don't make sense. So let's talk about some anti-patterns. The first is missing your threat model. It's always a mistake. Attempting to build any security-based solution without a threat model is always going to be a problem. This is how security theater happens. Teams start with a solution in mind, and then they design the threat that they think will happen to justify that solution. Just because you identify that some component in your architecture is vulnerable and a solution will work, you need to take another step after that, which is what happens if there's other components in your platform which have the same security vulnerability, and the solution that you've implemented in that place doesn't solve the vulnerabilities in those components. Well, you may have blocked attacks in one component, but if those other components have more sensitive data, then what value have you really added? You may hear things like, in the past, it was security by obscurity. I think that triggers everyone at this point. The new one is defense in depth. Do not trust when someone says that. That is not a threat model. That is some magic words that supposedly mean something. Yeah, for sure, stacked security solutions on top of each other may offer some benefit. But unless you've defined what that threat model is, it's a nonsensical statement. Focus on the threat. The next anti-pattern is internal services. I'm going to suggest there's no such thing as an internal service. There's just services that don't have any external requests yet. Threat actors may be able to get API requests sent to your services via lateral attacks through proxies or gateways or even other services in your platform that are forwarding along these things without doing proper validation. And if you've done your job, and I know we're all great software engineers here, which means the things we're building are going to be more and more valuable over time. Our customers may actually request direct access to them. If we've got a quote unquote internal service, then at some point that may need to be public. And if you haven't designed your service with that specific use case in mind, then you probably have the exact threats that I've outlined here in the common threat model right now. So it's much better to always treat all your callers as external malicious attackers. And even if they're from another team in your company, I for sure suggest that you'll see more DDoS attacks from other teams in your company using your services than you will from external callers. And most importantly, that your services are public in some way, even before they are. And the last one, the second to last one, is building monoliths. Now, I think that this is highly controversial, or so I've been told. But in 2024, I will say that microservices are more secure than monoliths. And that's because with microservices, we're forced to actually consider service-to-service communication. And when we think about that, we think about how do we secure that communication? And then we add in authentication and authorization and sufficient logging at the service level. We do all that work up front. That means that between the services, there's a fundamental boundary that operates as a bulkhead door that remains closed if one of those services become compromised. Whereas in a monolithic system, you have a bunch of components. If one of those components becomes compromised, then your whole system becomes compromised. Even if that component only talks to the database. If a malicious attacker compromises that component, and that means they have the ability to corrupt the database, which means that it will bring down your whole system. Building microservices encourages us to think about that cross-service communication and actually implement security in the right places. And the last one is building it and maintaining it yourself. Do not build what is not your core competency. It may seem like a clever way to avoid the supply chain injection attacks, but you're unlikely to be more effective at building and maintaining that component and rooting out vulnerabilities than a team of experts who specifically own and are validating that component as they built themselves. Now, the counter argument is always, what if it's a critical component? Well, the truth is everything's a critical component. I'm sure no one thought Log4j was going to be a source of vulnerabilities in our platforms, and you probably would consider logging a critical component. We don't have the resources to be able to effectively commit to stopping attacks if we have to literally build everything. I mean, how many companies out there in the world are literally making their own electricity? There are for sure some, but it's not a very high number. Okay, and with that, I'm going to have to say, I hope at this point you know how to at least a little bit better secure the APIs that you have, think about the threat models, and go a little bit further once you leave this room. I have a quick slide that includes the URL for this talk and some other ones, which will be up after I get home tomorrow. So don't check before then. And this is and this is me. If you want to connect or have follow-up questions later, thank you.
Hi. So I'm not a cybersecurity expert, but I've been in the field for 15 years.
That's an expert.
No. In a different field, I'm doing search engine optimization. So I work with the websites a lot, and a lot of them being hacked. So I need to protect them. So, but it without really knowledge in cybersecurity. And about DDoS, just a question about DDoS. It feels for me that it's getting less and less as a problem. Like it become less popular in the industry. because like Cloudflare and all that stuff is blocking it pretty easy and sometimes pretty cheap. Do you feel like that way, that DDoS is not a big thing anymore, or it's just my?
I mean, I hope that's the case, honestly. So, the question is DDoS still a thing? I think if you find some data from Cloudflare or any of the CDNs, Akamai, et cetera, you'll probably see a graph that actually like almost exponentially increases over time. And that's just the sad truth. I would say the best defense at dealing with those is Cloudflare or AWS's CloudFront or whatever one of the other proxies are that is out there. For sure, you still need to add those in to handle it. If it weren't the case, there's no way that Cloudflare and AWS would be able to charge an extra thousands of dollars per month to help you with a dedicated team to stop them. The larger your company is, the more you have to deal with this. I mean, I know at the FANG level or Manga or whatever you want to call the group of very large tech companies, they're dealing with this problem at just huge scales, massive on a scale. So hopefully you don't have to worry about it, but for sure it is a problem. And you should be thinking about some way of stopping these that are coming into your service.
Hello, I have a question. You told about different API vulnerabilities which can occur. And my question maybe applies to your personal experience. What do you think about using, for instance, SaaS solutions? I know that they provide many false positives sometimes when it goes about APIs attacks and other types of vulnerabilities. What do you think about those solutions? Do they help? And how can they help to protect APIs? Thank you.
I mean, we have a SaaS solution. What am I supposed to say? I mean, for sure, we're thinking about this. I mean, I think in the realistic, we're in the security space, so we are thinking about this all the time as a concern. I mean, so we are in a way an expert in that area. So I think there is a threat model where it's what data are we giving to them and whether or not we think that they can support it. But one of our unique selling propositions is that we look at teams at companies that we're replacing their software with our product. And we say that they're spending $1 million a year plus on just the team to manage that. And what we're offering usually eclipses that. So, I mean, you can definitely spin up a team to do it, but unless it's like, you're not going to have a team of security experts that are going to be better at securing that particular thing and being able to build it and effectively run it. Like most of the times when we're replacing software, it's because what is currently in place is not sufficient. It's not good enough. So you get a lot of features in play. I usually say the recommendation of if the company is driven by something other than their core competency, you should be concerned, right? That's a good thing. Don't forget about the features you see on the website. They're totally irrelevant. Forget about whatever promises or certifications they have, totally irrelevant. Like all the giant companies you've heard of who have gotten popped, I for sure they have every certification you've ever heard of and then some. It's not relevant. What's relevant is whether or not they're actually thinking about how to stop those attacks, whether or not that's important. So you need to look at their mindset over time. If that aligns with how you think about problems, then you're golden, use them. But if they don't, then you may want to go further. But unfortunately, you don't have time to build out every single component in the world. So you're definitely still stuck between a rock and a hard place.
Thank you. I have a question. What non-standard ways we can use to identify user? I mean, if using system of email, password, phone number is not enough secure for us.
Okay, so
or even using JWT is not enough secure.
Okay, so, well, using JWT is secure. I mean, I'll say one thing, like no one should be creating a new system today that uses phone numbers or passwords, like full stop. Passwords are inherently totally insecure, end of story. Phone numbers are equally insecure for any system that needs to have even a modicum of security. They're incredibly easy to duplicate or even just buy the phone number from the party who owns it, the telecom. So for sure, neither of those solutions. If you care about your user security, you'll do two things. You'll offer WebAuthn FIDO2-based authentication where they can plug in their YubiKey or whatever Titan key they've got into their machine to actually self-identify. That's for sure. But at the end of the day, when you get that verification in, you can convert that to whatever token format you want. But you should pick JWTs because there are libraries out there specifically tested and validated to be secure. Now, for sure, there are going to be vulnerabilities in everything, but there are going to be way less vulnerabilities when there's 10 versions of the library to pick from, and people are looking at that and validating it rather than something novel and custom into your specific environment.
Thank you for your presentation.
No
My
problem.
question is regarding Bola.
Yeah.
And do you think role-based or resource-based access control is usually safe every time? Because in my previous experience, I had a colleague that it has to do with Microsoft Exchange. And even though in Microsoft Exchange, basically they just add you to a distribution list or something like that. And with the fact that, it still has that role base, it was able to use that permission to penetrate into the Exchange server, because then it was not even Exchange Online, it was able to penetrate into the Exchange server and also get some access to some other servers in the infrastructure. So don't you think it's better than, when you have role-based access control, you should also, deny all other permissions aside the one that, you want to particularly give permission to?
Well, if you don't assign a permission, then that's by default deny. You shouldn't have to go out and also say deny. That doesn't make sense. I think there's two things here. First one, to answer your question, is resource-based access control more secure than role-based? Yeah, for sure, 100%. Like if you're specifically defining which resources they have access to, then for sure it's safer than role-based access control. But if your provider that you're utilizing is insecure, then it doesn't matter what you've got there. They may have a vulnerability that you can just get around. And I think we've seen that from one of the cloud providers has been negligent in realistically being able to prevent these sorts of attacks. And it doesn't matter if your control plane for that provider is vulnerable, then there's nothing you can do. It doesn't matter what solution that they put in place for you. They can say no one ever gets in. No one's allowed to access the Exchange server directly. But it doesn't matter, because if they do allow that access, then you've got a vulnerability. Adding explicit denies is the same problem. If the provider isn't correctly validating requests for the allows and implicitly denying, then offering you four-letter word as a token in a request to suggest that they're actually denying the request is nonsensical, right? Like if they don't have a real system that is free of vulnerabilities, especially in that way, you as a user adding in a deny policy doesn't really change anything.